This is one of the most interesting aviation crashes that I have ever heard of. In 2008, a mechanically perfectly intact Boeing 777 crashed just meters short of runway 27 left in London Heathrow, Europe's busiest airport. But why? Turns out that the evidence was long gone when the investigators were able to survey the crash site. Let's find out how they found the mystery cause of this accident anyway. Welcome to Airspace. On January 17, 2008, British Airways Flight 38 took off from Beijing for its 10.5-hour flight back to London Heathrow. This flight would for the most part be highly uneventful. En route, the pilots considered the weather along their flight path, which was normal by most standards. Only the expected outside air temperature was reported to be rather low at cruising altitude. Due to this, the crew decided that they would monitor the fuel temperature very closely. Usually, temperatures at cruising altitude range between -50 and -70 degrees Celsius. That's -58 to -94 degrees Fahrenheit. Therefore, it is crucial that the pilots monitor the fuel temperature, since the most commonly used aviation fuel, called Jet A1, starts to freeze at around -44 Celsius or -47 degrees Fahrenheit. While it freezes, it produces a waxy substance that can clog the fuel system and lead to engine flameouts. On normal flights, this fuel coagulation temperature limit is no problem, but on really cold winter flights or flights at high altitude near the equator, sometimes a descent to lower altitude with warmer air is necessary. But during the entire flight of British Airways Flight 38, these fuel temperatures remained at or above -34 degrees Celsius, well within limits. When the Boeing 777 reached London Heathrow, it was directed to approach runway 27 left. The aircraft was nicely configured and ready for landing when it passed 1,000 feet above the ground, about 3 nautical miles out from the runway. But just moments later, 57 seconds before touchdown, the thrust of the right engine reduced suddenly. Another 7 seconds later, the thrust of the left engine reduced as well without pilot input. Both engines did not stop running, but continued to provide a small amount of thrust just above idle values. Imagine stopping at a red light in your car. When you later want to drive on as it turns green, the engine is running, but as you push the accelerator, nothing happens. I bet you'd be baffled, just as the pilots of British Airways Flight 38 surely must have been. 27 seconds before touchdown, the aircraft's speed had now reduced below the planned approach speed of 135 knots. The pilots were now frantically searching for the reason of their engine's misbehavior. But now, the 777's computer warned the pilots that the airspeed was becoming dangerously low. The captain tried to ameliorate the situation by reducing the angle of the landing flaps from 30 degrees to 25 degrees, reducing the aircraft's drag by a small amount. The investigation later found that this action elongated the glide by some 50 meters. 10 seconds before touchdown, the so-called stick shaker activated. This is a device that shakes the control column of the aircraft, indicating to the pilot that the airspeed is now dangerously low and that the nose of the airplane should be lowered immediately. The first officer who was flying the plane did exactly that, avoiding a stall but increasing the rate of descent substantially. Seconds before impact, the commander transmitted the following Mayday call.
Mayday, Mayday, Speedbird, 95.
The first officer now tried to smooth the landing somewhat by pulling back on the control column. Unfortunately, he succeeded only partially since the aircraft's response was slow due to the low airspeed. The plane touched down hard 110 meters inside the airport fence, clearing a packed parking lot and a gas station by mere meters. It slammed into the grass 330 meters short of runway 27 left. During the ground roll, all landing gears collapsed and the right main landing gear separated from the aircraft. It hit the passenger cabin and its main strut punched a hole into the fuselage. Fortunately, no fire started after the plane came to rest. Fire and rescue services responded and were at the aircraft quickly. The commander initiated an evacuation, first on the radio frequency by mistake, then inside the plane.
Mr. Captain, this is an emergency. Evacuate.
The final report of the event describes the evacuation as efficient and fast, with some passengers trying to bring their carry-on luggage, a problem that often arises during evacuations where everything should be left behind. One passenger even decided to climb up on one of the evacuation slides to get his suitcase and evacuate once more. There were only minor injuries, with the exception of one unlucky passenger who was hit by the main landing gear strut when it hit the cabin. He received a broken leg. Could have been much worse, if you ask me. But what had led to the loss of thrust on both engines? Investigators were happy to find the plane in relatively good shape after the crash landing. In what I found one of the most meticulous investigations that I have ever read about, they attempted to find the reason for the malfunctions. Rather quickly, the investigators were able to determine that an obstruction in the fuel system must have caused the problem. They looked for foreign objects and found 5 pieces that didn't belong: a plastic scraper, 2 pieces of tape, and 2 paper snippets. All would have probably been left there by accident during the production of the plane. The presence of forgotten or misplaced foreign objects unfortunately is a recurring theme for Boeing planes. But in the end, the investigators determined that these items could not have caused the problem. They then went on to rebuild the fuel system of the Boeing 777 in a laboratory capable of reproducing the very low temperatures and high fuel flows experienced on the accident flight. What they found was truly astonishing. To understand the next section, let's first take a look at this engine part right here. It is called a fuel oil heat exchanger. Since engine oil gets very hot and jet fuel gets very cold in flight, this temperature difference is used to cool the engine oil and heat the fuel. Reproducing the environmental conditions experienced on British Airways Flight 38, the team was able to prove that ice can build up inside the fuel lines at fuel temperatures between +5 and -20 degrees Celsius. That's 41 to -4 degrees Fahrenheit. In that temperature range, the ice was described as being sticky, sort of like soft ice on a cone or slush. The water needed for this ice to form originates from the fuel itself, since all aviation fuels contain small trace amounts of water. As the flight progressively continued into colder air, the buildup of ice stopped when the fuel temperature dropped below -20 degrees, but the ice remained inside the pipes. As the aircraft descended into warmer air on approach, the ice started to soften again. A combination of warmer air and fuel at lower altitude, turbulence, and increased fuel flow due to the engine acceleration on approach led to a simultaneous release of large amounts of ice. This slushy ice then traveled down the pipework in what investigators described as a snowball, coming to rest on the face of the fuel oil heat exchanger. With the fuel lines protruding 4 mm outwards from the hot oil containment, the ice built up there, clogging up the heat exchanger almost completely, leading to a greatly decreased fuel flow and the loss of thrust in both engines. During the investigation, the team looked at data from 175,000 other flights of the same aircraft type and found out that of all of them, only British Airways Flight 38 fulfilled all of the unfortunate criteria that led to the significant ice buildup and release thereof during approach. There was one other Boeing 777 by Delta Airlines that experienced a similar problem at cruising altitude, but the conditions there were slightly different. After the cause of the accident was clear, Boeing modified the heat exchanger of the 777's Trent 800 engines by removing the protrusions of the fuel lines into the heat exchanger. This new heat exchanger proved to be much more capable than the old one, and a modification of existing parts was made mandatory shortly after. No other Boeing 777 has since suffered the same malfunction. The captain of the flight, Peter Burkill, left British Airways after the crash. The reasons as to why he left or was forced out are somewhat nebulous. In several reports, he stated that terrible internal rumors and stories began circulating soon after the crash. Apparently, according to these rumors, he had failed to declare a mayday call, froze at the controls, let his first officer handle the emergency, and eventually failed to conduct an orderly evacuation. After the crash, he was unable to find a job at any other airline. When the final report was finally published in 2010, 2 years after the crash, Peter Burkill was cleared of any wrongdoing. On the contrary even, his actions were praised in the final report. Half a year later, he was allowed to return to British Airways. Apparently, he and the company laid their grievances to rest, as the company openly welcomed him back, and Peter Burkill called British Airways the pinnacle of his career. So, what do you think about this accident? Let me know in the comments down below. I hope you liked my account of this amazing aviation story, which could have ended much worse. Longtime viewers of the channel might even have had a slight déjà vu, as this video is a remake of one of my very first videos here on airspace. If you liked it, leave a like and subscribe to the channel for many more interesting aviation stories. See you in the next one.